everyone. This video presentation is about the webinar I attended last meeting. The first webinar tackled about Internet of Things or IoT. So what is IoT? Internet of Things is a network of physical objects or people known as things, each of which is equipped with software, electronics, networks, and sensors to collect and exchange data. The purpose of the Internet of Things is to extend Internet connectivity from traditional devices such as computers, smartphones, and tablets to relatively simple items such as toaster. Virtually everything becomes smart as a result of Internet of Things, which uses data collecting, AI algorithms, and network to improve elements of our lives. Let us now discuss how IoT started. I made a timeline of the history of IoT. To begin with, in 1970, the concept of connected gadgets was first proposed. Then by 1990, John Romkey designed a toaster that could be turned on and off remotely via internet. Then in 1995, Siemens introduced the first cellular module built for M2M. M2M stands for machine to machine. Then in 1999, the term Internet of Things was used by Kevin Ashton during his work at P&G, which became widely accepted. Then in 2004, the term was mentioned in famous publications like Guardian, Boston Globe, and Scientific American. Then in 2005, the International Telecommunication Union or ITU of the United Nations released its first study on the subject. Then in 2008, the Internet of Things was born. And in 2011, Gartner, the market research company, included the Internet of Things technology in their research. So how Internet of Things works? The entire IoT process starts with the devices themselves like smartphones, smartwatches, electronic appliances like TV, washing machine, which help you to communicate with IoT platform. There are four fundamental components of an IoT system. The first one is sensors or devices. Sensors or devices are key components that help you to collect live data from the surrounding environment. All this data may have various levels of complexities. It includes a simple temperature monitoring sensor, or it may be in a form of video feed. The second one is connectivity. All the collected data is sent to a cloud infrastructure. The sensor should be connected to a cloud using various mediums of communications. These communication mediums include mobile or satellite network, Bluetooth, Wi-Fi, WAN, etc. The third one is data processing. Once the data is collected and it gets to the cloud, the software performs processing on the gathered data. This process can be just checking the temperature, reading on devices like AC or heaters. However, it can sometimes also be very complex, like identifying objects using computer vision on video. The fourth one is user interface. The information needs to be available to the end user in some way, which can be achieved by triggering alarms on their phones or sending some notification through email or text messages. The user sometimes might need an interface which actively checks their IoT system. For example, the user has a camera installed in his home. He wants to access video recording and all the feeds with the help of a web servers. This image shows the IoT application that can be applied in home, transport, health, buildings, and cities. IoT solutions are widely used in numerous companies across industries. Here are the list of common IoT applications. Smart thermostats help you to save resource on heating bills by knowing your usage patterns. Connected cars. IoT helps automobile companies handle billing, parking, insurance, and other related stuff automatically. Activity trackers helps you to capture heart rate pattern, calorie expenditure, activity levels, and skin temperature on your wrist. Smart outlets remotely turn any device on or off. It allows you to track a device's energy level and custom notification directly into your smartphone. Parking sensors IoT technology helps users to identify the real-time availability of parking spaces on their phones. Connect Health. The concept of connected healthcare facilities, real-time health monitoring, and patient care. It helps in improved medical decision-making based on patient data. Smart City. Smart City offers all types of use cases which include traffic management to water distribution, waste management, etc. Smart Home. Smart Home encapsulates the connectivity inside your homes. It includes smoke detectors, home appliances, light bulbs, windows, door locks, etc. Smart Supply Chain. Help you in real-time tracking of goods while they are on the road or getting suppliers to exchange inventory information. There are key benefits of IoT technology, or should I say the advantages of IoT. The first is technical optimization. IoT technology helps a lot of improving technologies and making them better. Example, with IoT, a manufacturer is able to collect data from various car sensors. The manufacturer analyzes them to improve its design and make them more efficient. The next is improved data collection. Traditional data collection has its limitation and its design for passive use. IoT facilitates immediate action on data. Reduced waste. IoT offer real-time information leading to effective decision-making and management resources. For example, if a manufacturer finds an issue in multiple car engines, he can track the manufacturing plan of those engines and solve this issue with manufacturing belt. The last one is improved customer engagement. IoT allows you to improve customer experience by detecting problems and improving the process. If there is advantages of IoT, there is also a key challenges of IoT, or should we say the disadvantages of IoT. The first is security. IoT technology creates an ecosystem of connected devices. However, during this process, the system may offer little authentication control despite sufficient security measures. The second one is privacy. The use of IoT exposes substantial amount of personal data in extreme details without the user's active participation. This creates lots of privacy issues. Next is flexibility. There is a huge concern regarding the flexibility of an IoT system. It is mainly regarding integrating with another system as there are many diverse systems involved in the process. Complexity. The design of the IoT system is also quite complicated. Moreover, its deployment and maintenance also not very easy. The last is compliance. IoT has its own set of rules and regulations. However, because of its complexity, the task of compliance is quite challenging. Moving forward, let's talk about IoT best practices. Design products for reliability and security. Use strong authentication and security protocols. Disable non-essential services. Ensure internet managed and IoT management hubs and services are secured. Energy efficient algorithms should be designed for the system to be active longer. Another topic discussed is internet connectivity. All IoT devices require mechanism to receive or send data. There are numerous options available for connecting devices to the internet, including wired and wireless options, Bluetooth, cellular networks, and many more. The option you choose depends on the various factors such as scale and size of network where the application will run, amount of data that needs to be processed and transferred, and lastly, physical location of devices. Internet connectivity for IoT devices. There are options and examples as shown in the image or the table. For the wired or Ethernet, food storage temperature monitoring as an example. Wireless or Wi-Fi as an example is soil moisture sensor. The next is Bluetooth. Key tracker as an example. Cellular data. While life tracker as an example, RFID or radio frequency identification, inventory management as an example. This represents the example of simulation software as discussed in the webinar. Another topic discussed is about web server and how it works. So web server is a place which stores and processes and deliver web pages to web clients. Web clients is nothing but a web browser on your laptops and smartphones. The communication between client and server take place using special protocol called HTTP or Hypertext Transfer Protocol. In this protocol, a client initiates communication by making a request for a specific web page using HTTP, and the server responds with the content of the web page or an error message if unable to do so. Pages delivered by a server are mostly HTML documents. Most connected IoT devices today are connected to the internet using a Wi-Fi connection. Although a Wi-Fi connection enables remote access to the internet, it has own limitations. For instance, in most industrial applications for a stationary device, Ethernet is usually chosen over Wi-Fi connection, simple because it is more reliable and secure. Since Ethernet is a wired connection, it provides better speed and a low latency. Another webinar conducted is about cryptography. For now, let us first define what is information technology security. IoT security is the protection of information, especially the processing of information. IT security is intended to prevent the manipulation of data and systems by unauthorized third parties. The security includes physical security, cybersecurity, and information security. IT security threat. So what is security threat? It is a malicious act that aims to corrupt or steal data or disrupt the organization system or entire organization. It can be passive threat, which is release of message contents or traffic analysis, or either active threat, like masquerade, replay, modification of message contents, or denial of services. Take a look at the image or the graph. This shows a common human error of data breach. 6% indicate system misconfiguration, 11% for stolen or lost device or records, 13% for others, 17% for inadvertent disclosure. Then the biggest percentage of common human error is phishing. Then 19% of each is network intrusion. So what is the security goal? There are three classifications of security goal. The first is confidentiality, that state or keeping secrets in private. Non-repudiation, it is the assurance that the sender of information is provided with proof or delivery and recipient is provided with sender's identity. Then the last one is integrity, the state of being whole or undivided. Now, from the main topic of the webinar, what is cryptography? It refers to secure information and communication techniques derived from mathematical concept and a set of rule-based. Let us now define encryption. There is advantages and disadvantages of encryption. Let's first discuss the advantages. Encrypted data can be easily read. Strong encryption may require years of work to decrypt without the key. Then the disadvantages. Encrypted files draw attention to their value. If you lose the key, you lose the data. For large files, strong encryption may take significant time to decrypt. Cryptography is categorized into two: the symmetric key cryptography and the asymmetric key cryptography. Let's first define the symmetric key cryptography. Symmetric encryption is an older method of encryption. It is faster and more efficient than asymmetric encryption, which take a toll on networks due to performance issues with data size and heavy CPU use. Traditional ciphers can be substitution cipher or transposition cipher. A substitution technique is one in which the letter, number, symbol of plain text are replaced by a letter, number, or a symbol. Transposition cipher is a technique wherein the position of letter, number, symbol in plain text is changed within one another. Another category of cryptography is asymmetric key cryptography. It is known as public key cryptography. It is a process that uses a pair of related keys, one public key and a private key. Cryptography can be applied in defense services, secure data manipulation, e-commerce, business transactions, internet payment system, user identification system, access control, or data security.